All right, we're going to practice doing the exact same thing with these, but we're going to figure out component form and our magnitude for each vector. So with this first vector, we're going to start at the point 3, 4, and it's going to end at the point -3, 5. So basically what we're trying to do is we're trying to move this back to the original, so we're trying to move this back to the origin. And once we move it back to the origin, where is the ending point? So we can either do that physically, or we can think about it. So the way I like to do it, thinking about it, is I like to count. So from left to right, this goes from the starting point to ending point. It goes left 1, 2, 3, 4, 5, 6. So my component form so far is -6 because I went left 6. And then from there, I just went up 1. So I went up 1. So there's my component form. So then to find my magnitude, this is just going to be the square root of, it is 6 long, so I do 6 squared, plus, and then it's 1 tall. So 1 squared, because this is Pythagorean theorem, we're just solving for that lost piece. This is the kind of shortcut. So this ends up being the square root of 37. Okay, let's do that again. So over here, we're going to draw our vector, which starts at 0, 4, and it ends at -3, -2. So there's my thing. So going from starting point to ending point, I go left 1, 2, 3. So component form so far is -3, comma, and I go down 1, 2, 3, 4, 5, 6. -6. There's my component form. Then using Pythagorean theorem, we're going to do the square root of 3 squared plus 6 squared, which is 9 plus 36. That'll be the square root of 54, which becomes a decimal, so we're just going to leave it as square root of 54. Okay? Alright, I want you guys to do the exact same thing. Now go ahead and give this one a shot. Sketch the vector and write it in component form, and then write the magnitude. Alright? And write it not as a decimal, write it as a square root. Okay? We'll come back together right here.